So here in example 1, we want you to find the equation for the image of the graph y equals 5x squared under the translation t sub negative 2/3 6. So notice that h is negative 2/3 and that k is 6. So in our basic formula for vertex form, y minus k equals a times the quantity x minus h quantity squared, we're going to take this number negative 2/3 and plug it in for h, and this number k and plug it in for this number 6, and plug it in for k. The a value, which is 5 in our equation, will remain the same. So our equation will be y minus 6 equals 5 times the quantity x minus negative 2/3 is plus 2/3 quantity squared. Once again, I want you to notice what I emphasized in the previous video. You see the opposite in the equation. So in the equation you see a plus 2/3, which means it's going to move left 2/3. And in the equation you see a plus 6 for the k value, which means it's going, in the rule you see a plus 6, but in the equation you see a minus 6, which means it's going to move up 6 places. It kind of seems opposite of what you would think it would be, but you discovered through our tasks yesterday that that is what happens. So this particular parabola has a vertex at negative 2/3 6. And that's because the parent, or the original function, y equals 5x squared, has a vertex of 0, 0. If there are no pluses or minuses, they always have a vertex of 0, 0. So in example 2, we're asked to graph the equation y minus 2 equals negative 2 times the quantity x plus 3 quantity squared. We can certainly put this into our calculators to determine the coordinates of the vertex, but that's really not necessary. We did ask you to graph, so of course we'd want to graph. Now remember, you've got your table function on your calculator, which is second graph, which allows you to see points that are on this parabola. Be careful in one like this, though. Well, I guess not. This will give you points that are on this parabola. If I look at the h and the k, what is subtracted from x is negative 3, because in the equation it's x plus 3. What is subtracted from y is 2, because in the equation it's y minus 2. So when you graph this on your calculator, you're seeing that vertex, which is a maximum vertex, at negative 3, positive 2. Now just to add a little bit more to this one, the axis of symmetry, which is that vertical line that goes right through the vertex, will have all of its x coordinates equal to negative 3. So the axis of symmetry has the equation x equals negative 3. And again, if you recognize from the equation that the vertex is at negative 3, positive 2, then when you go to second graph, you'll be able to find other points on that parabola that you can plot on both sides of that vertex when you're asked to do this on paper, which you will be asked to do. We might ask the question, how is this graph related to the graph of y equals negative 2x squared? Well, first notice that they have the same a value. So they're going to have the same amount of spread away from the vertex. But what's different is obviously that this vertex of our new graph is at negative 3, 2. As I said in the previous example, an equation that's in the form y equals ax squared will always have a vertex at 0, 0. So if we ask how are these graphs related, we can say that this one is a translation of the y equals negative 2x squared, 3 units to the left, so h would be negative 3, and 2 units up, so k would be positive 2. Now we might also have a question like this where we're asked what the image of the point xy will be under a translation 3, negative 2. Now remember, in this rule, it's telling us that this is moving 3 to the right, and it's telling us that this is moving 2 down. So we know that in the equation we would use the opposite operations, but I'm just asking in this equation what the image of xy is. So what's happening to the point xy on the coordinate plane? Well, if xy say we're at 0, 0, what that basically means is that it's going to move 1, 2, 3 places to the right and 1, 2 places down. So we would describe this as a translation 3, negative 2. So the image would be the original x coordinate would have 3 added to it, and the original y coordinate would have 2 subtracted from it. Now when we go to put this in the equation, we of course know it would be y plus 2, the opposite operation, equals a, whatever the original a value was, times the quantity x minus 3, the opposite of the rule, quantity squared. So in example 4, we're asking you to sketch a graph of the equation y plus 3 equals 1/2 x squared. What we notice is that the a value is 1/2. So if we sketched y equals 1/2 x squared, we would see that it meets has a vertex, at 0, 0. But our equation has nothing added or subtracted from the x, so the x is remaining the same, but it has 3 added to the y in the equation. So that basically means that on the coordinate plane, 3 will be subtracted from the y. So the image of xy will land on xy minus 3. So this will be a translation. 0 units right or left, but 3 units down. Now to sketch it, we've got the help of our calculator. We can enter this equation, y plus 3 equals 1/2 x squared, into y1, and then once again we can go to second graph, and we can see all sorts of points that lie on that parabola. We'd like to plot some that are to the left of the vertex, as well as some that are to the right of the vertex. Now we might ask you to give the equation of the axis of symmetry. So again, it's this vertical line that goes right through the center of the parabola. A vertical line is always in the form x equals a number. Well, what is the x coordinate of this vertex? It's 0. So that means that every point on that vertical line has the same x coordinate. So the axis of symmetry has equation x equals 0. Finally, in this lesson, we might be asked to solve a quadratic equation for x, where we've got something like x plus 3 quantity squared equals 64. The first thing we would need to do would be to get rid of that squaring on the x. So we would need to square root both sides of the equal sign. When you square root a quantity squared, you get just that quantity. But you've got to remember that the square root of 64 is both 8 as well as negative 8. We talked about this in lessons 6.1 and 6.2. So I'm going to need to set that x plus 3 equal to positive 8 and also equal to negative 8. So to solve for x, I'm going to need to subtract 3 from both sides. I'll get x equals 5, or if I subtract 3 from this equation, I'll get x equals negative 11. So either one of those values, 5 or negative 11, will work for x. Here's the way to check it. If you take 5 plus 3 and you square it, do you get 64? You do. I'm just substituting my answer in for x. If I take negative 11 plus 3 and square it, do I also get 64? Well, negative 11 plus 3 is negative 8, and when you square the number negative 8, that's like taking negative 8 times negative 8, and that is also equal to 64. So you know your solutions are correct. So have we hit our targets? We've used the graph translation theorem to interpret equations of parabolas that are translations as well as their graphs, and then we can graph those parabolas and interpret those graphs. If you have any trouble as you're working on these questions in Lesson 6.3 from the book, please don't hesitate to email me, and I'll be sure to make some additional videos in the evening tomorrow, or in the evening today as your Wednesday, December 10th, to kind of guide you through those. So don't hesitate to do that. Have a great rest of your day, guys. See you tomorrow.